Welcome to the DIY Honda Garage channel. The DTC P0141 refers to an issue with the secondary heated oxygen sensor, HO2S heater circuit. This sensor is crucial for monitoring the amount of oxygen in the exhaust gases, allowing the engine control module, ECM, to adjust fuel delivery for optimal combustion. It is located downstream in the exhaust system, often after the catalytic converter. The heater circuit within this sensor ensures it reaches the necessary operating temperature quickly. When this circuit malfunctions, it can lead to improper sensor readings, affecting engine performance and emissions. Therefore, understanding the operation and importance of this fault code is critical for effective troubleshooting and repair. The secondary heated oxygen sensor, HO2S, a key component in the exhaust system of the Honda Civic, plays a major role in measuring oxygen levels post-combustion. It helps maintain optimal air-fuel mixture, thereby improving fuel efficiency and lowering emissions. Found after the catalytic converter, this sensor's primary function is to facilitate timely detection of the exhaust gas composition under varying conditions. The heater circuit within the secondary HO2S ensures that the sensor reaches its operational temperature quickly, allowing accurate readings and proper functioning. If the heater circuit fails, it could lead to delayed sensor response, ultimately affecting engine management by providing erroneous data to the ECM. Remember, proper functioning of the secondary HO2S is vital for both performance and compliance with emission standards. Several factors can lead to a DTC P0141 error. A short in the heater circuit is one potential cause, which disrupts the electrical flow necessary for sensor heating. An open circuit in the heater, on the other hand, indicates a break in the wiring or connector, leading to a lack of continuity. This condition can prevent the secondary HO2S from operating as intended, which may trigger this fault code. Additionally, a faulty secondary HO2S itself can lead to malfunctioning of the heater circuit, necessitating sensor replacement. Each of these issues requires careful inspection and testing to ensure accurate diagnosis and effective repair. Addressing these components can help restore the sensor's functionality and ensure compliance with emission regulations. When DTC P0141 is present, various symptoms may become noticeable during vehicle operation. One of the primary signs is poor fuel economy, as the engine may be running inefficiently due to incorrect sensor data. Increased emissions are another concern, which can lead to failing emissions tests and potential legal ramifications for the vehicle owner. Additionally, drivers may experience engine performance issues, including rough idling, stalling, or sluggish acceleration. These symptoms not only affect the driving experience, but can cause further damage to the vehicle if left unaddressed. Thus, recognizing these signs early is crucial for timely interventions, ensuring both performance and compliance with emission standards. The first troubleshooting step for addressing DTC P0141 involves turning the ignition switch to the on/to position. This state powers the vehicle's electrical systems, allowing for diagnostic testing. Before proceeding, it is essential to record all freeze frame data, which stores information about the vehicle's parameters at the time of the fault. This data serves as a valuable reference point during diagnosis. The next step is to clear the DTC using the Honda Diagnostic System, HDS, which restarts the fault detection process. Once cleared, the next phase is to start the engine to verify if the code reappears, indicating a persistent problem. This critical first step lays the groundwork for more detailed diagnostics as it assesses the initial fault condition. After clearing the DTC and starting the engine, The next step is to check for any pending or confirmed DTCs using the HDS. This diagnostic tool allows technicians to evaluate the performance of the vehicle's electronic systems, highlighting any active or intermittent faults that could relate to the secondary HO2S. If DTC P0141 is indicated again, it confirms that there is indeed an ongoing issue with the sensor or its wiring harness. Conversely, if no DTC is shown, it suggests that the failure may have been intermittent, and further inspection of connections or terminals may be needed. This step is crucial for understanding the scope of the problem and determining whether it needs immediate or long-term solutions. In troubleshooting step 3, turn the ignition switch to the lock 0 position to ensure safe handling of electrical components. Following this, inspect the number 3 alternator 10A fuse located in the under-dash fuse/relay box. The integrity of this fuse is crucial, as a blown fuse can disrupt the power supply to the secondary HO2S heater circuit, causing the DTC to trigger. Document the condition of the fuse, as it can provide significant insight into potential electrical issues. If the fuse is intact, you may proceed to the next troubleshooting step. However, if it's blown, this indicates a possible short in the circuit that must be repaired, along with replacing the fuse. This step is essential for confirming the vehicle's electrical health and functionality. In step 4, after checking the number 3 alternator fuse, you must determine its condition. If the fuse is found to be blown, the first action is to repair any shorts in the circuit leading to that fuse. This is crucial, as an uncorrected short could lead to recurrent fuse failures, resulting in ongoing DTCs and possible engine performance issues. After rectifying any underlying electrical problems, replace the blown number 3 alternator 10A fuse to restore electrical continuity. Once these actions are completed, you should return to step 22, which is indicated in the diagnostic process, ensuring all repairs are thoroughly documented. This step emphasizes the importance of proper electrical management in maintaining vehicle performance and preventing future issues. Step 5 requires disconnecting the 4P connector from the secondary HO2S sensor 2. This allows for testing the sensor's electrical parameters without influence from other vehicle systems. Next, measure the resistance between terminals number 3 and number 4 at the sensor side, which should provide insights regarding the health of the heater circuit. According to diagnostic specifications, a proper resistance reading ranges from 5.4 to 7.3 ohms at room temperature. If the measured values fall within this range, it indicates that the heater circuit is operational. If the readings are outside these parameters, this suggests a fault within the heater circuit, leading to further steps to diagnose the underlying issue. Thus, this step is pivotal for assessing whether the secondary HO2S heating element is functioning correctly. In the 6th step of troubleshooting, check for continuity between body ground and the terminals number 3 and number 4 of the secondary HO2S 4P connector individually. This step evaluates whether there is a reliable ground connection for the heater circuit. Continuity means that an electrical signal can pass freely, which is essential for the heater circuit to function correctly. If there is no continuity, it points to a potential problem such as a wiring issue or loose connection, which may need repair or replacement. Identifying any faults here ensures that the sensor can receive the necessary power for its heater to function properly, ultimately affecting vehicle performance. Hence, this step is vital for ruling out grounding issues that could trigger DTC P0141. After completing repairs for DTC P0141, it's essential to conduct a final verification process. This involves rechecking the functionality of the secondary HO2S to ensure that the heater circuit operates as expected. Verify all connections and repairs made during the troubleshooting process to confirm that no new issues have arisen. Once satisfied with the repairs, operate the vehicle under normal conditions and use the Honda Diagnostic System, HDS, to confirm that the DTC has cleared. If DTC P0141 does not reappear, it indicates successful remediation of the issue. This final step is crucial to ensure lasting reliability and avoidance of future faults, ensuring the vehicle returns to optimal performance. Preventive maintenance for the secondary HO2S and its heater circuit involves several proactive measures. Regularly checking electrical connections for corrosion, wear, or loosening is essential to maintain reliable operation. Monitoring sensor performance helps in early detection of any functional discrepancies, allowing for prompt repairs. Additionally, ensuring that the exhaust system remains clean can prevent buildup that could impair sensor operations. It's important to be attentive to signs of performance issues. Addressing these early could prevent major problems and foster longevity for the vehicle's emission system. Incorporating these practices into routine vehicle upkeep can significantly enhance. In summary, understanding the role of the secondary HO2S and the implications of DTC P0141 is crucial for effective vehicle maintenance. Systematic troubleshooting includes evaluating electrical connections, measuring resistance, and assessing the entire heater circuit to identify faults. Performing each step methodically ensures accurate diagnosis and timely repairs that enhance vehicle performance and reduce emissions. Additionally, regular preventive maintenance checks can save time and repair costs while increasing vehicle reliability. Key factors include maintaining sensor functionality and addressing issues as they arise. This holistic approach to vehicle maintenance promotes longevity and optimal operation for the Honda Civic. Please like and subscribe to the channel. See you next time.